Hi everyone. In today's lesson, we're going to solve by factoring. So we have been working on factoring so that we can solve these quadratics using this method. All right, remember graphing quadratic functions in intercept form. Y equals a times x minus p and x minus q. What did we call p and q? Do you remember? Okay, so one of them was we called them x-intercepts. The other one we called them solutions. We also call them zeros on the calculator, okay? Sometimes they even call them roots, just so you know. All right, so intercept form of a quadratic is the same as writing a quadratic in factored form. Look at it. This right here is intercept form, and this right here is the factored form. It's the same. The only difference is here you have a y equals, and on this side you have a equals 0. Now, when we work in intercept form, we just took the opposite of the numbers being added to x. Now we're going to learn why. There is this thing called zero product property. We shorten it to ZPP. If a times b equals 0, then a equals 0 or b equals 0. In order for two numbers to equal 0 when multiplying, one of these numbers has to be equal to 0. Since we don't know which one, we set both of them equal to 0 and solve for the value. All right, let's look at it. So we can use this to help us solve quadratic equations after we have factored them. Here are the 3 easy steps to help us remember how to solve a quadratic by factoring. 1. Set the quadratic equal to 0. We're going to go ahead and use ZPP, but the only time we can use zero product property is if it equals 0. Factor using GCF, a difference of squares, or trinomial method. So we'll see which one we need. And then set each factor equal to 0 and solve for x. So these are the 3 methods we're going to be using. We have 4 examples. We're going to try this on. Now, example 1a, I'll zoom in a little bit, says solve the following quadratic by factoring. The good news is it's already factored. So I can go ahead and do zero product property, which means set 2x minus 3 equal to 0, add 3 to both sides. 2x equals 3, and then divided by 2 on both sides, and x equals 3 divided by 2. And then you can also do the same thing with the other factor. 3x plus 6 equals 0. Subtract 6 on both sides. 3x equals negative 6 divided by 3, and x equals negative 2. These are our 2 solutions for the quadratic. Well done. Now, in example 1b, what you're going to notice is that they have given you a quadratic that is not factored. But if you recall, this right here is called the difference of squares. Perfect squares, to be honest. Which means that we can go ahead and factor really quickly. X squared breaks down to x and x. Well, 9 is also a perfect square, so you can break it down to 3 and 3. 1 is going to be positive, 1 will be negative, and then you're going to set it equal to 0. Once we have the factors, we can set each factor equal to 0 and solve each one. Subtract 3 on both sides, and x equals negative 3. That's one of our solutions. And add 3 for the other factor, and x equals 3. That's the second solution. All right, well done. Now, let's go to 1c. If you look at 1c, once again, it is not factored, but we do have a GCF. 5 and 15 have a 5 in common, and x squared and x have an x we can factor out. So I'm going to take out a 5 and an x, and then I'm going to ask myself the question, what's left over? Well, if I take out a 5 and an x, I'm only left with one of the x's from the 2. Plus, if I take out a 5 from 15, really 5 times 3 is 15. So if the 5 goes out and the x is gone, we're just left with a 3 in place of the 15x. So now we have our 2 factors. A lot of people think 5x is not a factor, but it is. It looks kind of odd, but it is. And then x plus 3 equals 0 as well. So zero product property. Each factor is equal to 0. Solve 5x equals 0 by dividing both sides by 5. And x equals 0 divided by 5 is 0. You can even check that on your calculator to verify my work. And then you're going to go ahead and subtract 3 for the other factor, and x equals negative 3 is our second answer. So here are the 2 answers for our quadratic. All right, now let's look at our last problem. The last problem looks so scary, and the reason for that is we cannot start working on this until one side is equal to 0. So what I am going to do is move 6x squared to the other side, and I put it right underneath 7x squared because they are like terms. Then I'm going to go ahead and add 4x to the other side, and I'm going to put it right by 5x because they are like terms. And then I'm going to go ahead and subtract 22 on both sides, and I'm going to simplify. Now, 7x minus 6x is 1x squared. Negative 5x plus 4x is negative 1x. And 10 minus 22 is negative 12 equals, and then the right side cancels all out to a 0. And once we have it as you see it written here, what you should notice is that the left side of the equation is called a trinomial because there are 3 terms and we need to factor. The question becomes, what adds to negative 1 and multiplies to negative 12? So we got to find 2 numbers that's going to meet that criteria. I always remember it as AM, kind of like morning time. All right, x squared breaks down to x and x. And 2 numbers that add to negative 1 and multiply to negative 12 would be negative 4 and 3. Negative 4 times 3 multiplies to negative 12, and negative 4 plus 3 adds to negative 1. So therefore, my 2 factors are x minus 4 and x plus 3. Once we factored, we can set each factor equal to 0 and solve each one of them separately. Add 4 on both sides, and x equals 4, and then subtract 3 on both sides, and x equals negative 3. Awesome job! Well, this is all I have for you and how to solve by factoring. I hope this video helps. I can't wait to see you in class. Bye-bye.